Hi everyone, I'm Chacharis, your physics teacher in Senior 6. So still we are in production of full sound waves, but we want to give you an example where we are having vibrating strings. Let's give an example and see how to apply the formula. A piano is 1.10 meter long and has mass of 90 grams. How much tension must the string be under if it is to vibrate to a fundamental frequency of 131 Hz? B. What are the frequencies of first four harmonics? Great. Don't you see that for this case, piano with 1.10 meter long, don't you see that the example of vibrating string? Of course. So let me remind you the fundamental formula for this case. The frequency with a number of harmonics is equal to the speed over the wavelength depending to the number of harmonics, which is equal to the number of harmonics times F1. But you may ask yourself, what is F1? Very interesting. Now, F1 is equal to 1 over 2L times tension divided, square root of tension divided by mass per unit of length. What is this really? Nothing else apart from the speed. To mean the speed is equal to, here the speed was equal to square root of tension over mu. Remember mu, that's mass per unit of length. Now here the wavelength was equal to 2L, as L was equal to wavelength divided by 2. Okay, now we apply the formula. So this is what we call fundamental frequency for this case. Let's come back to our question. If a piano is 1.10 meter long, so we have some data. Okay, we have some data. Solution. So we have the length, that is 1.10 meter, and it has mass. We have the mass 90 grams. 90 grams, that is 9 times 10 to power negative 3 kilograms. So how much tension must the string be under if it is to vibrate to a fundamental frequency of 131 Hz. Now, let us first find the fundamental by using this formula. By using this formula, don't you see that F1 is equal to, and that the fundamental is equal to 1 over 2L times square root of full tension divided by mu. Can I square both sides? Very simple. That's F1 squared is equal to 1 over 4L squared times tension divided by mu. Because the square will remove these square roots. So, can I do cross multiplication? Of course. Now, I have F1 times 4L squared times mu is equal to tension. Now, if this is the tension, do I have mu? Do I have the length? Do I have the frequency? That's very simple. Because mu, that is mass per unit of length. That is 9 times 10 to power negative 3 divided by 1.10 meter. You may ask yourself, why are you changing into kilograms? Because I cannot use the grams with this meter. I need to change into the SI units. Now this is mu. So I can apply this formula. That tension will be equal to F1, that's 131 Hertz, times 4 times length squared, that is 1.10 10 squared times mu, that is 9 times 10 to power -3 over 1.10. So when you find the tension by using your calculator, you are going to find that the tension will be equal to 600. The tension is equal to 696 newtons. $679 newtons. So that's the tension. Don't you see that it is very necessary to remember that the speed is equal to this, okay? And by studying them, you can find the tension. They may ask you the length, they may ask you the mass per unit of length, so they may ask you the frequency, but that's the frequency, the first harmonic. Now, if you were having the first harmonic, and remember the formula of the first harmonic, or F1, was equal to 1 over 2L times square root of or tension over mu, and you have seen that Fn was equal to V over lambda n, and this was equal to n times F1. Now let's go to the second question. They were asking, find other harmonics. Okay? So just to apply the formula, remember we are on vibrating strings. One of the production of sound waves. Now, if I have F1 was equal to 131 hertz, okay? Now, what will be F2? We just use the formula. Fn is equal to NF1. So far we have F1. So the second harmonic, that's F2, will be equal to 131 hertz times 2. That is 262 hertz. F3 will be equal to 131 hertz times 3. So F3 will be equal to 393 hertz. So F4 will be equal to 131 times 4. Don't you see that's very simple? Just know the formula. If I know the general formula, and I know this is the first harmonic, I know the first harmonic, then, or the fundamental frequency, it is very simple to know the formula. So to me, the key points of understanding this unit, specifically production of sound waves, it is a matter of knowing which case do I have. I have open at both ends, open at one end, close at both ends. So that is the case of vibrating string. So that is the 400, 500, that's 1, 3, 1, 4, that is the 4, 12, 1, 4, 5. That's 524, 524 hertz. So these are the 4 harmonics. 1, 2, 3, 4. Okay? So the 1, 2, 3, 4. The first one, the third one, second one, third one, which is this. Okay? Then the fourth one. Great. So far, now we have seen production of sound waves. And this was an example which helped us to apply sound waves. So by next time, we are going to focus. Do you remember characteristics of sound waves? Do you remember properties of sound waves? Great. If you remember them for properties, we were having reflection, we were having refraction, we were having diffraction, we were having interference. But we are going to focus next time for interference. How can I calculate the interference? Because remember, most of you are going to do engineering in university. So it is better to know this because it will help you for further studies in your universities. So next time, let us focus on interference. And thank you very much the way that you were attentive in understanding production of sound waves in 3 cases. So more details can be found on our YouTube channel, which is Ikaram TV. But also on our website you can find other lessons, www.ubumenyi.net. You can find other lessons of Senior 6, but also other lessons of physics in Senior 1, Senior 2, Senior 3, Senior 4, Senior 5, Senior 6. So thank you very much, and thank you for watching this video. Ciao, ciao. I love you, Senior 6 students. See you. I'm Tia Charles.